Hello, I'm Roger Bertman from ROLM Corporation, and I'm going to talk for a few minutes about ISDN. About the ISDN standards, what they are, how they've evolved, and what some of the key driving forces behind those standards has been to this point in time. I'll discuss what some of the values are that you, the user, would hope to achieve from ISDN and how the standards activities have been addressing themselves to those values. I'll talk about ROLM's position with respect to ISDN and our commitment to ISDN, and finally offer a perspective on how the issue of ISDN might be considered in the decisions you have to make with respect to the acquisition of telecommunications equipment and services. To begin with, ISDN is really two things. It is a set of standards, a set of interfaces, and it is a set of applications and services which ultimately provide value to you, the user. The first component of the ISDN standards that I'd like to talk about is the channel structure of the ISDN interfaces. There are two ISDN interfaces being defined. First of all is the 23B plus D, or ISDN primary interface, which is comprised of 23 call channels and a single signaling channel. Secondly is the ISDN basic interface, or 2B plus D interface, which is comprised of 2 B or call channels and a single signaling channel. Under both of these interfaces, the B channels carry voice calls or data calls or other information, and the signaling channels are used to communicate between ISDN networks and equipment to allocate bandwidth amongst the call path channels. The next component of the ISDN standards are the protocols that define how information is passed in an ISDN environment. These protocols are arranged in a set of layers, and the lower layers define the physical and logical characteristics of an ISDN interface, while the upper layers define the applications characteristics which would ultimately provide applications and services to the user. The ISDN activities to this point in time have focused very heavily on the lower layers, defining the characteristics that the equipment vendors and the service providers must understand in order to have a basic set of protocols over which to accomplish applications. Very little effort has been devoted to this point in time in the applications portion of the protocols themselves. Now, to understand how ISDN is going to evolve in this country, you must understand the network structure of telecommunications networks in the United States. And because of deregulation, as you know, that structure is comprised of a number of different networks. That is, there is not a single network through which a call now traverses to go from one location to another. As this picture depicts, in fact, a call leaves a customer's premises and goes first of all through a local access transport area, or LATA, in order to access an inter-exchange carrier, and then traverses that carrier's services to get to another LATA and ultimately to another premises or the destination of the call. Now, the arrows that are shown between the LATAs and the inter-exchange carriers here depict the common control signaling number 7 interfaces that must be accomplished between these multiple ISDN networks in order that true ISDN capability be accomplished. The dotted line indicates that there are telemetry paths required, again CCIS number 7 paths required, between central offices, from the originating central office to the terminating central office, via the inter-exchange carriers, in order again to accomplish ISDN connectivity. Now, these interfaces have not been decided upon at this point in time. There is delay in the deployment of CCIS number 7 in the central offices, particularly of the Bell operating companies. And so until all of these interfaces are totally worked out, there cannot be a single cohesive ISDN network or ISDN service provided from a user perspective. Let's look now at some of the potential values that ISDN represents to the user. We believe there are two key values that we would hope to achieve from ISDN. The first of these is control of transport costs, control of the costs incurred in transporting information from one location to another through various network vendors' services. The second is comprehensive connectivity. That is, the ability to have connectivity from a single device to many other devices, host computers, and public data networks, and so forth. The key to controlling transport costs with ISDN is to be able to leverage the competitive environment that now exists amongst telecommunications network service providers. Typically, a single switch, CBX as shown in this picture, would be connected to a variety of public switch network providers and a variety of services within each of those providers, and we would like to be able to use ISDN to properly select the right service and the right vendor for each application that you, the user, have, in order that you might most effectively spend your telecommunications service dollars. Now, network service costs, as you know, comprise the majority of your telecommunications budget, and controlling these costs can offer one of the greatest leverages of ISDN value that I know of. In order to make that happen, we absolutely need to have unified, universal ISDN standards, and we need to have intelligent premises-based equipment. Premises-based equipment that allows you to have software that can select amongst the various vendors and the various services in a dynamic fashion. Comprehensive connectivity refers to the capability to access multiple devices, public data networks, host computers, and so forth, for both voice applications and data applications from a single terminal, and to be able to do that ubiquitously. Again, in order to accomplish comprehensive connectivity, we must have a universally accepted set of standards, and we must have intelligent premises devices, controllers and CBXs and so forth, that can implement those interface standards. So to summarize the ISDN user requirements, we need really to have two things in order for ISDN to be truly of value to the user. First of all, we need to have detailed, well-defined, and universally accepted standards. Secondly, we need to have an intelligent set of premises devices, CBXs, PBXs, controllers, terminals, and so forth, that can allow the value of ISDN to be tapped. Having understood now what the user requirements of ISDN are, let's look at where the ISDN standards are at this point in time. First of all, there's multiple participation from diverse organizations in the ISDN standards activities. There are a number of standards bodies, CCITT and ANSI and ECMA and so forth, who are driving the ISDN standards activity. There also are a number of network service providers and manufacturers who are interested in ISDN and are playing a key role, particularly in this country, in the composition of the ISDN standards. Each of these manufacturers and service providers has its own vested interest with respect to what it needs to do with ISDN or wants to do with ISDN. There has been very little input at this point in time from the user community, who really are ultimately to benefit from the capabilities of an ISDN network. And as a result of that, the standards as they exist today are both incomplete and are contested in some ways. They're incomplete in the sense that the final recommendation of the CCITT will not happen until the 1988 plenary meeting, and they're contested in a number of ways. For example, the U interface, as it pertains to interconnecting a device on a customer's premises to a central office switch, has not been finalized at this point. The PBX to PBX signaling issue has also not been addressed. PBXs in the ISDN standards today are always a slave to a central office switch, and the notion of a PBX comprising a key element of a private ISDN network for a user has really not been addressed. And data rate adaptation for sub 64 kilobit data into a 64 kilobit ISDN channel has also not been finalized. There also are a number of ISDN trials that you've heard about. Let's talk about what the status of that activity is. All of the RBOCs, all 7 of them, have scheduled ISDN trials, and some of them are beginning soon. They will be completing in the 1987 and 1988 timeframe, but those trials even really comprise ISDN islands within metropolitan areas. The CCIS number 7 links between those ISDN islands will not be trialed in these various initial trials, and the equipment that's being used is preliminary equipment and prototype equipment. So the trials are important. They're important to watch and keep aware of, but they are not an implementation of ISDN as a real network service. Let me offer a perspective on the ISDN standards and trials activities to this date. All of those activities have been driven by carriers and telephone companies, both in this country and in Europe. And in particular in the United States, it is AT&T and Bellcore who are really interested in driving the formulation of ISDN standards. Why is that? It's because they are the first to accrue the benefits of ISDN. As AT&T and other inter-exchange carriers and the regional Bell operating companies are able to define the interfaces between their respective networks, they will be able to more efficiently manage and administer their networks and hence have a lower cost basis. Additionally, the inter-exchange carriers and the RBOCs are using ISDN as a competitive differentiator. They know that you want to be able to pick between multiple service vendors, and they want to use ISDN to offer some value-added service that might cause you to want to choose their service. And once they have an interface, a so-called ISDN interface, for example, to which you are connected, they have you locked in to using their service to the elimination of others. So we've seen that each of the inter-exchange carriers and the operating companies have their vested interests, and we've even seen that a number of them are announcing products, so-called ISDN products, to promote their individual interests. AT&T has announced a number of services, a number of products, both premises equipment and network service equipment, that they claim to be ISDN products. Northern Telecom has announced ISDN products and would have you believe that the premises equipment to central office relationship will be best implemented by a vendor who manufactures both of those pieces of equipment. But again, the key issue is having ISDN throughout the network service vendor environment as well as the central office and premise equipment environment. The regional Bell operating companies are offering ISDN as one of the key ways to enhance Centrex service. Again, a particular vested interest that they are representing. Now, all of these products that are being talked about, these ISDN products, do offer ISDN kinds of functionality and ISDN kinds of services, but they absolutely do not represent true ISDN capability. ISDN standards don't exist, they have not been finalized, and the equipment and services that you buy today under the statement of being ISDN compatible will most assuredly need to be changed in the future as those standards become finalized. We've also heard a lot of talk about how, gee, we must have ISDN compatibility today. If we don't have ISDN compatibility, we won't be able to hook up to the service vendors, and we won't be able to communicate at all. Well, that is sheer nonsense. ISDN will evolve over time. A change as revolutionary as ISDN will not happen overnight. It will take a long time, and we will in fact see a coexistence of ISDN and non-ISDN and even digital and analog services for a long time, at least for the next 20 years. So it's important to understand that there will always be ways other than ISDN to communicate, and in fact, ways to do so in a very efficient and effective manner prior to ISDN becoming ubiquitously available. So to summarize the status of ISDN, we've seen that the standards at this point in time are incomplete and are contested in many ways. We've seen that the standards activities have been driven by the inter-exchange carriers and the telephone companies, and that they have focused on the interfaces rather than the applications, and therefore necessarily on network control rather than user control over telecommunications services. And finally, we've seen that ISDN will absolutely be an evolutionary rollout. It will take place over a long period of time, and that as the rollout of ISDN becomes more clear and applications become available to satisfy user needs, there will be ample time to take advantage of the ISDN capability. Now let's talk about ROLM and ISDN. First of all, ROLM is an impartial participant in the ISDN activity. We do not sell central office switches, and we are not a network service provider. so that we do not have a vested interest in how the standards unfold in terms of keeping the functionality and control in the network or central office. Secondly, we are focused, as we always have been, on user requirements, and we are an advocate of the user. And thirdly, we have always adhered, and we continue to adhere, to the principles of ISDN. Let's consider what those principles are. First of all, digitization is a fundamental principle of ISDN, and ROLM was the first PBX vendor to offer a digital CBX. And the success of that CBX and the digital telephones that connect to that CBX have in fact been renowned. Second key principle of ISDN is software-based intelligence. The feature software and the least cost routing software of the CBX has always been superior and will continue to be so as we focus on the needs that you have to utilize intelligent devices to meet your needs. Thirdly, standard interfaces. We have always met all of the standard interfaces and always will do so of the user. We have integrated T1 interfaces, we have integrated X25 interfaces, and all manner of analog trunk interfaces in the CBX. Another key tenet of ISDN is the integration of voice and data. ROLM was a pioneer in integrating data switching into a voice PBX. And we were a pioneer in integrating voice and data on a single link, that link called ROLM link, which interconnects the CBX to a ROLM digital telephone. And that gets to the final tenet of ISDN, which is common control signaling. ROLM link is an ISDN basic-like link. It contains 2 B channels and a common control signaling channel, 64 kilobits of voice and data, and we have 1 million copies of ROLM link that have been sold and are being used today in user environments. So we understand the basics of ISDN functionality. So ROLM has always adhered to the principles of ISDN, and we're committed to ISDN as a way to bring enhanced value to our users. We're aggressively representing the needs of the users in standards bodies today, and we're aggressively developing ISDN products today. ISDN is a key component of our connectivity strategy, but not to the exclusion of the other interfaces that you will require to have a total solution to your problems. So it seems to me, as you think about ISDN and the decisions that you're making today, that you have one of 2 focuses you can make. You can focus on the interfaces, the standards, and the network service providers and central office switch providers who have driven those standards, or you can focus on the value, the applications that ISDN promises to deliver to the user. And as you focus on the value of ISDN, I can assure you that ROLM and IBM will continue to be, as we always have been, totally focused on the needs of the user and on the needs of customer premises control over his telecommunications environment. I will further say that ROLM and IBM are totally committed to ISDN, and that we will deliver ISDN functionality and ISDN interfaces as our users require them. Thank you very much.